Hi, we are a group of students from UM that are taking GHG0055 Healthy Planet, Healthy Life. In this video, we will talk about the GHG analysis that we have conducted at the Faculty of Sports and Exercise Science. So, let's get started. Alright, so in this video, we'll be covering introductions, data result, GHG calculations, data analysis and explanations, as well as our conclusions. Did you know that University of Malaya has introduced the UM sustainability policy to work towards being a sustainable university? This policy is based on the Sustainable Development Goal (SDGs) and serves as a guideline for all members of University of Malaya to be part of the global sustainability movement. One of the policy highlights the importance of low or zero emission from transportation such as cars and motorcycles due to the harmful GHG emitted by motorized vehicles. GHGs are naturally emitted from sources such as animals, volcanic activity, and decomposing biomass. These emissions are typically balanced by natural processes like photosynthesis in plants. However, human activities have significantly accelerated the buildup of GHGs in the atmosphere. In this assignment, our group will focus on analyzing the amount of GHG emission produced by sports and exercise science faculty at the University of Malaya. Specifically, we will examine Scope 1 emission, which are direct emission from sources that are owned or controlled by the faculty. Our analysis will focus on GHGs produced by the burning of fossil fuels from the vehicles owned by the faculty.
Next, I will be presenting about the data results. Results were obtained from the Assistant Engineer of the Faculty of Sports and Exercise Sciences for the period from January to December in the year of 2003. This is an example of the data provided by the data owner showing dates, locations, times, odometer readings, trip meters, and so on. Since the faculty exclusively used one car model for transportation, the fuel consumption for each month was solely petrol. Bottom Persona 2023 in Malaysia exhibit a fuel consumption of 6.6 liters per 100 kilometers. From there, the fuel consumption rate for each kilometers is calculated for each month respectively. In January, a total of 33.86 liters of petrol were consumed and the number was multiplied by 2.35 to get the GHG petrol, which is the 79.571 liters. In February, the total petrol consumed is 90.9 and the GHG petrol is 23.265 liters. In March, the total petrol consumed is 19.21 liters, whereas the GHG petrol is 45.144 liters. In April, there is no records of fuel usage in the logbook, therefore no GHG petrol were used. In May, the total petrol consumed is 38.54 liters and the total GHG petrol is 90.569 liters. In June, the total petrol consumed is 35.24 liters, whereas the GHG petrol used up is 82.814 liters. Table shows the fuel usage in August 2023 to December 2023 from Faculty of Sports and Exercise Sciences. In July, there are no fuel usage in the faculty, whereas in August, the GHG petrol use is 34.122 liters, 23.101 liters of GHG petrol were used in September, and 46.836 liters of GHG petrols were used in October 2023. Lastly, in November and December 2023, the GHG petrol use is 33.182 liters and 6.855 liters respectively. To sum up, the total GHG petrols used throughout 12 months in 2023 at Faculty of Sports and Exercise Sciences is 527.458 liters.
Okay, so right now I'll be presenting the GHG calculations for the first 5 months of the year 2023 at the Faculty of Sports and Exercise Science, University of Malaya. So first, let's take a look at the conversion factor used for our calculations. Petrol emits 2.31 kilograms of carbon dioxide per liter. So we use this conversion factor in our GHG formula, which is equals to emission in kilograms of carbon dioxide equals to fuel consumed in liters multiplied by 2.31 kilograms of carbon dioxide per litre. Now, let's go through the monthly breakdown in January. So in January, 17.97 litres resulted in 41.87 kilograms of carbon dioxide, 20.05 litres resulted in 46.3155 kilograms of carbon dioxide, and 11.08 litres resulted in 25.5948 kilograms of carbon dioxide, making the total for January is 113.3973 kilograms of carbon dioxide. In February, 9.9 litres were consumed, emitting a total of 22.869 kilograms of carbon dioxide. As for March, 19.21 litres were consumed, emitting a total of 44.5651 kilograms of carbon dioxide. As for April, no fuel was consumed, therefore it resulted in 0 kilograms of carbon dioxide emitted. As for May, it is a 38.54 litres consumed, emitting a total of 89.0274 kilograms of carbon dioxide. So from this breakdown, it helps us understand our fuel consumption and corresponding carbon dioxide emissions over the period of these 5 months. Okay, so moving on, let's take a look for the month of June 2023 until November 2023. In June, 35.24 litres were consumed, emitting a total of 81.4044 kilograms of carbon dioxide. As for the month of July, similar to April, no fuel was consumed, resulting in 0 kilograms of carbon dioxide. In August, a total of 14.72 litres of petrol were consumed, emitting a total of 34 kilograms of carbon dioxide. In September, 9.83 litres were consumed, emitting a total of 22.7073 kilograms of carbon dioxide, whereas in October, a total of 19.93 litres of petrol were consumed, emitting 46.0683 kilograms of carbon dioxide. And as for the month of November, 14.12 litres were consumed, emitting a total of 32.6172 kilograms of carbon dioxide. Okay, so last but not least, in the month of December 2023, 29.3 litres of petrol were consumed, emitting a total of 67.683 kilograms of carbon dioxide. So adding all the monthly emissions, the total GHG emission for the Faculty of Sports and Exercise Sciences for the year 2023 are approximately 554.33 kilograms of carbon dioxide. So from this, it gives a comprehensive analysis which highlights the fuel consumption patterns and their environmental impact throughout the year 2023. Thank you.
The data collected over the 12-month period in 2023 at the Faculty of Sports and Exercise Science provides detailed information on petrol consumption for vehicle usage. This information includes monthly fuel consumption in litres and was used to calculate greenhouse gas, which is also known as GHG emission, using a standard conversion factor. The conversion factor used for petrol is 2.31 kg of carbon dioxide per litre. This factor was applied to the monthly fuel consumption data to determine the GHG emission for each month. The highest emission were recorded in May, which was 89.0274 kg of carbon dioxide, and in June, which was 81.4044 kg of carbon dioxide, which indicates a period of increased vehicle usage during both of these months. There were no emission in April and July, which indicates that there were no vehicles being used during those months. The total annual GHG emission of the faculty was 554.15 kg of carbon dioxide, which highlights the impact of vehicle usage within the faculty. While this is a specific snapshot, it provides a baseline for the future comparison and assessment of emission reduction and strategies. To mitigate the greenhouse gas emission associated with the vehicle usage at the Faculty of Sports and Exercise Sciences, we recommend promoting alternative transportation options such as electric vehicles and encourage the use of public transport and carpooling. Introducing more electric vehicles within the faculty, supported by necessary infrastructure like charging stations, can significantly reduce the emissions of carbon dioxide. Additionally, ensuring consistent and accurate data collection across all months and implementing real-time monitoring system will provide better insights into vehicle usage patterns. Regular maintenance of vehicles to ensure optimal fuel efficiency, along with driver training programs focused on eco-friendly driving practices, can further contribute to reduce fuel consumption and emission. These combined efforts will help the faculty to reduce its carbon footprint and promote sustainable practices.
In conclusion, based on our analysis, the total GHG emissions over the 12 months period in 2033 amount to 554.15 kg of CO2. While this figure may seem low and suggest that the Faculty of Sports and Exercise Science does not significantly contribute to the university's carbon footprint, it is crucial to consider the cumulative impact of emissions from all faculties at the University Malaya. When combined, this emission can result in a substantial overall figure. In line with Universities Malaya's sustainability policy, the Faculty of Sports and Exercise Science must also align itself with the university's visions of sustainability. Therefore, actions must be taken by the faculty to reduce GHG emission. By implementing the recommended strategies, the faculty can effectively lower its emissions and contribute to a more sustainable environment. Thank you.